Well, we are back, and as I'm sitting here now in my front yard, the first thing I'm wondering is if I can write off my lawnmower to cut my grass, because we're in my front yard filming, and I, gotta cut the grass so we can film. Think that's legit? No? No. Anyway, we have the factory part now for this car. We left off showing some serious frustration with two different parts that failed parts, and what we had found out too. I believe we have this on camera. When we talked to my brother at the very last thing, he said that the Napa part that he used was an Eklund and it did not work, and then they sent him one that was Bosch and it did work. So I have my friend John who works for Hyundai. Special thanks to John for getting me this part. He works for Hyundai. We ordered the part from them and he brought it to me. And so we have a genuine Hyundai part now. And go figure, this is a Bosch part. Here, let me show you. There's our part number. And pulled it out of the bag. It's made by Bosch. So that makes sense. The one that my brother used on the last one that he dealt with, Bosch worked for him, where the aftermarket ones did not. So I wanted to review a couple things before we get going here. Number one, the bidirectional test that I showed when we did it with the engine running had around a maximum, and correct me if I'm wrong here, Caleb, it was between 11 and 13% was the duty cycle command for the running bidirectional test. So we will recreate that one. I'll show you guys that. We definitely want this thing to open during that bidirectional test with the engine running, and that was done during the Evap test. So we didn't have a running bidirectional test that we could command independent of the Evap test, and what we saw was around 11 to 13%. So we definitely want to see vacuum coming from this valve when we do that condition. The second thing is the normal purge during startup. And what we used later in the video is we started the car, instead of doing the bidirectional forced evap test, when we started the car, we found that the normal purge gave us a higher duty cycle percentage. And when I raised the RPM, we were able to achieve around a 30%, 35% duty cycle when I raised the RPM during a normal purge. And we're gonna do that same test again. I just wanna make sure that you guys are clear on what we were doing during that test. And so a purge valve, one of the times that it will be active would be on startup, especially when the engine's hot, because you have accumulated fuel vapors in the canister and we need to purge those. And so you start the car, it stabilizes, then it starts the purging process. And when you raise the RPM, the engine can handle more fuel. And so that's why the duty cycle percentage went up. And so that's what we were doing there with the startup purge. So we'll try to show that again too. And then something else too, the key on engine off bidirectional test that I showed initially when we put the valve in, if you guys remember, I was blowing through it and we were doing the test and I was like, it's working. I can blow through it when the command was there and when the command was not, blow through it. But I said that it felt a little funky, like at times it was better than it was when it was turning on and off. So sometimes it was decent, sometimes it felt like it was less. Not really sure about that, but I want to redo that test as well. But this time I want to show you guys the duty cycle percentage, because that's the only time that that valve worked by the engine computer. I was able to make the valve work by jumping it myself, but the only time the valve worked when the engine computer was commanding it with a pulse width or duty cycle was during the key on engine off test. And we don't know what that duty cycle percentage was because I never measured it. The most we saw was, like I said, about 30 to 35%, and we had no vacuum still. And I believe the key on engine off bidirectional test is going to show us a much higher percentage, which explains why the valve worked, because we have a higher percentage. Just like using the jumper wire would have been full 100% on, the closer we get to the 100% number, that valve's gonna start working. What we don't know about the valve yet is it a mechanical problem or is it an electrical problem? So we'll do resistance measurements on both of the coils, amperage measurement on both of the coils, and then we should be able to make that determination. And then the final thing before we get started is the vacuum gauge. Now I want to be clear about what we're going to see is when this valve works and I shut it off, vacuum is going to get trapped in here, because normally the purge valve works in conjunction with a normally open vent valve in the back. And so when we apply vacuum, as soon as we shut that vacuum off, it's going to bleed out. But when I'm using a vacuum gauge, there's nowhere for that to bleed. And so when we pull a vacuum, see if I can duplicate it. Watch the needle. Just a real simple concept here, but watch. Vacuum, then I pinched it off with my hand. So even though the valve will shut off, we're still going to see vacuum because it's trapped in there. So you're going to see me repeatedly unplugging it from the valve to get good test. And that's why I'm doing it, because I have to bleed that vacuum off. So let's get to it. And listen, if this doesn't fix it, I said this to Caleb, if this doesn't fix this car, I'm quitting auto mechanics altogether. I'm quitting. Video, ScannerDanner, everything. I'm quitting. All right, so this is the Napa brand part that I'm measuring first. 16.31 ohms. This is the factory Bosch part. 15.75 ohms. So very, very close. Resistance number wise, we could show the current flow to each, but what I want to do first before I do current is let's just make sure that it works. Wouldn't you agree? Let's make sure that it works, and then the rest of this we can talk a little bit more about. So let me swap this over. All right, so first thing we're going to do is just the normal purge startup, and that'll be with the mass airflow unplugged. So we'll have a mass airflow code. What you guys may have seen on the scan tool already was our Evap large leak, and then we had an open purge valve code. That's because I had the electrical connection unplugged, so don't get stuck on that. But we'll show the duty cycle percentage during a normal purge and whether or not we're getting vacuum to our tank, whether or not the purge valve is actually opening this time. All right, lab scope is still set up from when I used it last. Yeah, and this is a key on, engine off duty cycle. It's already being controlled. So remember, that's about 1% duty cycle, and that valve is off right now at that percentage. It's weird to talk about an on time and still saying that the component is off. So 1% duty cycle is not enough on time to make a strong enough field to open that valve. Maybe some of you would question, well, why have it pulsing on and off when it's not even working right now? Or when it's off, why would you have an on-time pulse when the valve is mechanically closed? And the answer to that is in having the valve be reactive quickly to when the command is applied. And so that's what they're doing. In fact, it just shut off. That's weird. Or did I lose connection? Yes, it did not shut off. I just lost connection. So really that's what it's about. It's just about control of the valve and having it be very responsive, in my opinion. That's why they do that. So just to, again, I have the vacuum hose removed from the line that goes to the tank, and we're going to measure right there. So that would be the inlet to the purge valve. As soon as that duty cycle changes, I want to start seeing some purging taking place. Again, that's about a 1%. Between my cursors is about 10%. There's some movement in that just because it's resting on the car and it's vibrating. That's nothing yet. I don't remember if it, with the mass airflow unplugged, it's possible that it doesn't purge. So we have to consider that too. It's still not purging yet. Let's see what she does. I don't remember if I had to have the mass airflow plugged in for a purge to take place. I might have. There we go. Yes, sir. That's only a very small percentage. Let's get a number. You know what? All right, you guys see the pulse. I need to go to this duty cycle scale so I'm not guessing. And that's going to be on our graphing meter. And so we have a digital number we can look at too. So that's 1% duty cycle. And I have vacuum trapped in here right now. So let's get that vacuum not trapped. So 1% is not enough, no vacuum when I raise it. There's a 6% duty cycle. We're already seeing the vacuum gauge move. Even at 6%, this is a fix, Caleb. This is a fix, 6.2%. Try to get it. That's awesome. So even at a 6% duty cycle, we started to see that vacuum gauge move. That means the bidirectional test is gonna pass now as far as the Evap test goes. So let me show you that one. System tests. Oh, I gotta clear the codes first. This is the one I had to have the mass airflow plugged in for, because it won't let me run the test with a code. Now it's gonna set a code because I have the vacuum hose still unplugged, but I have to have this plugged in to be able to show the running Evap Purge test. I wanna show you guys at 11%, we should have that vacuum gauge moving. I mean, I showed it to you at 6, so there's no reason it's not gonna move at 11. Let's clear these codes. System Evap monitor test. Let's make sure we have no vacuums trapped in there. I think I didn't check my engine temperature. Hopefully that's warm enough. Let's see what she does. We're still at 1.8%. That number should climb whenever it turns it on. There we go. 6. We were able to get 11% out of it last time. Oh yeah, look at that. 13%, look where it went. At 13%, we got full vacuum. How do you justify this cost to not only the garage, but the customer? What do you do? I mean, this is one where I really feel like a labor claim needs to be made. You know, here in the US, what we can do when we have bad parts is we can submit a labor claim to the auto parts supplier, and they pay, the auto parts supplier pays the shop labor time, because a customer shouldn't be paying for this. 3 parts, so the original one's bad, the Duralast one that was put in was garbage, the Eklund brand that was put in, garbage, the factory one, so 4, took me 4 to get a good, well, including the original bad one. The original one was bad, it was not purging at all, it was stuck, typical Hyundai. This is purging right now, you can hear it, and that is at 11%. 11%, nice purge. Raise the RPM, went even higher. Should be some good audio here. All right, sweet. So what else do I need to show everyone? This is definitely fixed. We could run the normal Evap purge, and it's gonna fail right now because the purge line is off. So I'm gonna have Evap large leak code. That's normal because I got the purge line off. Key on engine off one. I said I was gonna show you guys the duty cycle of the key on engine off test. And I said as I was blowing on it, if you guys remember during this test, that even the faulty parts would work. So turning it on, and let's see what the duty cycle command actually is. Yeah, no wonder it worked. So this is pulsing on and off. And when it's pulsing on, it's pulsing it at 98%. So does that make sense, Caleb, on why I could blow through it? So even the bad part, if you remember, when we started, I was blowing on it, I'm like, I'm like, you guys are gonna have to take my word on it that as that thing's being turned on, I can blow through it. Same thing this valve did. It works. Why is it working? Well, higher duty cycle percentage, stronger magnetic field opens the valve. Same way when I jumped it myself, I could make it work. But the lower percentages, you saw I had full vacuum at like 13%. Again, that number can be a little skewed because it's not open. There's no vent going on. It's closed in a system. So it wouldn't quite be that high with the vent valve being open and connected to the system. I'm sure it would be lower than full flow at 13%. I hope that makes sense. But that's why it works key on, engine off. The command, look at it. It's huge. Let me show it to you. That's on the pulsed scale. Here's the view of it. Remember, on time is the low portion. This very interesting looking pattern. All right, let's talk about this for a second. Let's go. Pause that, zoom out. All right, to the right of my dotted line cursor is very small on times, and to the left of my dotted line cursor in the middle of the screen is very long on times. Notice though that the frequency stays the same. Same frequency, variable duty cycle. It's a complicated subject, duty cycle, pulse width, frequency. Guys, listen, I have some great lectures on this exact subject, doing some live tests with a variable control solenoid on a scope on the screen, and talking about it with my class, ScannerDanner Premium. That's where you're gonna find that. You guys need to sign up. You're missing out on some great foundational knowledge when it comes to this kind of stuff. Again, to the left, look how long the on time is, and look how short the off time is. Off is high. Why is the spike so high? Because of a collapse of a magnetic field. But just remember that the low portion near zero is your on time. The off portion, which would be battery voltage, which you can see in here, that's battery voltage. That's the off time. But why the spike? As soon as that field collapses, it induces voltage and makes a spike. That was something else I wanted to show, was the height of that spike. We talked about that. It buried my scale. So let's go 100 volts. And yeah, it's going to 50.6 volts. As it's cycling the on-off period. You can hear it too. Listen to it. Okay, that's new valve. Let's get a amperage measurement while we're doing that. We can do all of this, key on, engine off.
Where you got?
I'm just taking some tape off here so I can get my amp. Let me see your knife.
For such a time as this, I'm prepared. Yeah, look at this cool knife. You can find that in the ScannerDanner Amazon affiliate link.
Did you put it in there?
No, but I should. It's been in multiple videos.
So I am connected my voltage lead on the control wire, the yellow wire, and I have my current clamp on the yellow wire as well. As far as current flow, you can go on either wire, but that's just the one I chose. So we'll measure current flow and voltage and at the same time, and the purpose of this is to see if we can make a call on why these other parts were not working. We don't know if it's mechanical or electrical yet. It's looking like it's mechanical because the resistance values were very, very close. Real quick shot down here for the snap-on scope users. Channel 1 needs to be connected, has the extra ground lead. That's where that's gonna go for your channel 2, which is gonna be my amp clamp. And a lot of people want to connect the red to red. That is not the way it's done. We're going to channel 2. You can use channel 4, but a lot of people will put it over there, match the reds, and then turn on channel 2, not realizing that they're not connected properly. So this is not red, so you connect it to red. It's a universal amp clamp. Channel 2 is going to be my amp clamp. We'll hit the home tab, go to my scope, and all I need to do is turn on my second channel and then tell my scope what I'm using, which is my low amp probe and my 20 amp scale. And then we got some definite noise going on in this thing. That should not be that high of amperage. Why am I showing that? Zero that probe. There we go. That's on a 2 amp setting. Let's go 5 amp. barely see it on there. Now let's go back, turn our bidirectional control on. So at 100% duty cycle, let's pause this, talk about that screen. So the off period is where the spike is. This is a very long on time, about 98% duty cycle. So your amperage up in here, up in this area, shows a max of 0.77 of an amp. We can pull a cursor in and not guess. Cursor 1.66 of an amp. So 0.6 of an amp, 600 milliamps for the on time of this factory part. And I'm gonna stop that and let's save all of this. Save all frames. Then we can go back and measure this later. But that's really the one we're interested in. Screenshot that. And then all I'm gonna do is plug this one in. I'm gonna leave everything connected as it was. I'm just plugging this guy in. And it sounds different because it's echoing there. 0.71, it looks identical. Let's pause that. Let's make that noise stop. Go back, take a look at this, zoom out. It's pretty darn close. Maximum voltage 50.6 on the spikes. The amperage in this area during the on time, which is in there, is 0.77. So if anything, a little bit higher of amperage. So what's that boil down to? Electrically speaking, in my opinion, from what I'm seeing here, you know, without looking at detailed comparisons, which you guys will be able to do much easier in the edits, but from what I'm seeing here at face value, this electrically is completely fine. It was constructed properly, and that just leads us to the internal mechanical parts of this valve were not made properly. And it would be great if I could take this apart and a factory one apart and compare the two, but I cannot. We need to get our money back. This thing's worth 60 bucks to my son. So that's going back to the parts store, and I don't have a new one or a factory part to take apart for you guys. But yeah, if this video isn't a lesson on why we need factory parts at times, then I don't know what is. I mean, this is one that I can't imagine some of the stuff that has been replaced for this problem. This is a common problem. A lot of you guys have seen this and maybe just weren't aware of what the actual issue was. Factory part was the fix. And again, who pays for it? You know, for us, we paid for it in the form of, how many times have we looked at this car now? Original time, we just swapped the part. We were parts changers. And we built it in a bad part. As soon as we changed that part, it went from a purge valve problem to an evap leak code. We attributed that to a purge valve that was faulty, that the computer couldn't do the leak test on, and that's why that code wasn't there. Not the case. The code was being set by a purge valve that would never open when it was supposed to. And so that's one. Second time, we went to my brother's shop, and you guys are gonna see that here, where we did smoke tests on the whole system, and I said, Caleb, there's no leak in here anywhere. We even checked the purge valve, I think, at that point in time, and I said, Caleb, put a gas cap on it. That didn't fix it. At that point, we determined that the purge valve was most likely the cause, and it was a bad Duralast part, and so we got another one. Put this one on. Exact same problems. What do you start doing when you have in a situation like that as a tech? You start second guessing everything, and you start saying to yourself, there's no way I got two bad brand new parts. Guys, we got two bad brand new parts. And are you confident enough in your knowledge to be able to say that that's what the problem is? Because most of us are not, myself included. I start questioning everything. What did I do wrong? What did I miss? And then unfortunately, the guys in the field that maybe don't want to go deeper into it, and they have, 10 cars waiting for them outside, they're going to throw another part on it. And then guess who pays for it now? Customer pays for it. That's what happens. It's a shame. And this is not an isolated incident as far as parts go. In my opinion, I've seen more crap parts in the last few years than I've ever seen in my entire life. And something's got to change. This isn't right. I see a lot of my friends on Facebook forums, and I see posts from you guys too, that you're just getting bad parts. Really, really tough situation. This is a fix. We're done. Caleb, thanks for enduring me through this, because I wasn't so kind to Caleb the whole time, like today. I was giving him a little mechanic speech. I'm like, listen, when you pull the car in the shop, step number one is you put the window down, leave the key in the ignition. What did he do? Window is up, door's locked. All right, so I think we're done. The only other thing I was gonna tell you guys that I could do is the Evap service bay test, but we have a full tank now, just about a full tank right now. And if you remember from before, that test doesn't run properly unless we're below 80% and above 20%. So there was a range for fuel. And so I don't feel that it's necessary to do that test anyway. We've proven the concept. Guys, I hope you learned something here. And I know we did. And we're gonna bring that knowledge to you guys too. I'm excited to hear your feedback on this. Thank you so much for joining us. We'll see you. I am irritated though. I'm irritated that I'm at this car again. We have an Evap large leak code again, and it was good for a couple of days. Light was off, all was well. Light came back on, Evap large leak. And I'm super frustrated. I don't know what's going on. I have a couple of theories. One, I'm concerned of the gas cap that was replaced. Did we put the correct cap on? Remember, it was replaced incorrectly. It never needed a gas cap. And then two would be, this was in a situation where it wasn't purging for a long time, and it is possible maybe that we got pieces of the charcoal canister that got trapped into the purge valve. Maybe that's what happened with the original valve, and I never looked at that. Remember, we just changed that part because of a code. Anyway, I don't know what's going on, so let's get back on the car and see what we find. Hey, don't dig in Dale's yard. Yeah, so we have the dogs with us, and if you hear some random yelling by me or some growling and horseplay, yeah, that's these two clowns. All right, I suppose my first thing I want to do is that Evap test. Let's clear this code. Although, let me see if any freeze frame data helps me. I doubt it will, but let's look anyway. Super frustrated by this car. Can't believe I'm looking at this again. All right. 186 degrees, 66% fuel level. So she was sitting still when the car set the fault. We have a commanded Evap purge rate of 15%. And of course, they don't give me tank pressure or any other relevant info that could help me. Not helping me there. Just pick some mode 6 data, not that this will help us. Let's see if it does though. This is the purge flow monitor. Value of 4. It passed, so it passed the purge. Yeah, I can't really go by these. I don't trust it because it should have had a purge flow code before and it never did. Evap monitor 0.9, so that's leak size. I picked the biggest one. Yeah, none of this is really gonna help me. It is neat, we can see parameters though. So mode 6, onboard monitored systems. This would be something you could use if you had something that was borderline and you wanna see how close it was to failing or how it failed. That's where your mode 6 data comes in. I don't use it much myself. There's our large leak code. I'm gonna clear that fault so I can run this test. I want to check the gas cap. I have the door open. Let's just go back here real quick. I just want to see if she has this tight. So when I check a gas cap, I don't want to take it off. I just want to grab it, turn it, and see if it clicks first. And that cat, I actually tightened it. It was loose.
Was it?
Yes, it definitely was loose. Not by much, but it was loose. All right, so the end of our last segment when we were finished, after proving our purge valve was faulty, 2 brand new parts, garbage, factory part, perfect. I did run the onboard system test, the Evap test, to force it to do its thing. And I watched the fuel tank pressure change, and then it failed the test. and it came up Evap large leak code again, and I said to Caleb, I'm just gonna disregard this because I don't believe it, and we cleared the faults and let it go. And so it's back with a large leak code. I should have maybe believed it. I don't know. But I'm gonna run that test again. Let's see what happens. Where are our dogs? Get up here. Pot, come here. Come here. Get up here, front yard. Stay in the front yard. So we have a half tank, we should be good. My engine temperature's warm enough now. Engine's idling, no other DTCs. We cleared them, so hit and continue. Engine's already running. That shouldn't be a problem. I hope it passes. If it passes, we're done. It was a loose gas cap. And then I can make fun of Liz for... You get that in the shot?
Yeah, it was right in the middle.
Oh, it's leaking. Penny's like, yes, sweet. Pa's like, watch out, give me some of that. Fuel tank pressure, let's see what it does. Running the tests, minus 12. Purge valve's definitely working. Test complete, no leak detected. It's Liz's fault.
It was my fault.
That cap was loose.
Oh, yeah, that's her fault.
Look, my day just got a whole lot better. I mean, it failed. We should have listened to it. It's my fault for not listening to this test. So this one's on me as a technician. This one's on me because we had almost, okay, I remember why we in part disregarded it. Our tank was almost full. It was above 8. Well, remember I was looking for a data PID for tank percentage and I couldn't find one. And we said that that was possibly why we got a false test here. Anyway, what a nightmare this car has been. And I'm really, truly thankful this is family, because in a shop situation, this whole thing's a basket case. There's no way you're gonna convince the customer of really anything that was done this far into the job. And man, what a nightmare. But I'm grateful for this. I feel comfortable that we can give this back, and I'm just kind of dumbfounded by that being listed as a large leak when I didn't tighten it that much. I'm anxious to see in the footage. Again, like you said, Caleb, I really felt like I wanted it to be loose. It is also possible that that had nothing to do with it, and we have an intermittent sticking purge valve from pieces of charcoal canister that are stuck now in the purge valve. That is a possibility, and we may have like round 5 with this car, but I'm gonna call this a fix and just be happy and count our blessings and clear the codes and let her take it. We're calling this a fix for like the 4th time. I wonder if I slightly loosen the gas cap again and run this test, if it passes with a slightly loose gas cap, then I'm gonna quit. But I said that before. So let's see. Cycle the ignition off, then on before the next test. Got it. Key off, I'll wait 5 seconds. Key back on. Let's rerun this test. Start the engine. Oh, it's decaying. Test complete, no leak found. I just need to see something here.
Are you just going to loosen it a little bit more?
Yeah, that's really loose. Yeah, that's really loose now. If this passes, then I can't trust this test. Turn the key off again. All right, the gas cap's like completely loose right now. All right, let's watch what it pulls down to. Test passed, no leak found. You know, I thought we were done with this car, and I thought it was a loose cap. I'm just taking the cap off this time. This is stupid. So now why was it setting? You remember when we smoke tested this originally, like we had no smoke coming out of the tube? Like there's a check valve in the tank, and putting pressure on this side like closed it. I don't know. Evap systems are stupid. I can't wait till cars are all electric and we don't have to deal with this crap. This is with no gas cap. Oh, it's definitely not able to pull down. Okay, good. That makes me feel better. To trust this test, that makes me feel better. It definitely is gonna fail. Attempted, okay, due to DTC, and then our large leak code, sweet. Okay, I feel better about that. It is still possible. It was gas cap, it was loose, and you know, maybe it just me initially tightening it with it loose and not having the vibration of going down the road. You know, it was making a good seal while sitting here. That's my only explanation for that. Does that make sense? So you got a surface here, right? The tube, then you have an O-ring that tightens on it. We're just sitting still right here, and I just tightened it loosely, and that could make a good seal, it being loose. But when you go down the road and that cap is loose, and now it's not gonna sit in a good position anymore with road vibration, and then we fail the test. So we're going with that. I'm sticking with it. If the car comes back, we'll let you guys know, obviously. How many rounds are we in on this? We should have run the test. That's pretty cool, showing the failure. You guys, I know, will like that, seeing it pull down, and then how long it held compared to with no cap, where it hardly pulled down at all and the pressure was rising. I'm gonna put the cap back on and do this one more time. All right, let's clear this code. We're gonna run this test one more time. Watch it fail this time. No leak detected. All right, we're calling it a fix, clearing the codes.
Is there anything else you can check, or you just...
No, this is it. I mean, there's no reason, there's legit no reason for me to pull anything apart on this car and do any of the checks we did before. In the footage, Caleb, you're gonna see when you edit this, when I ran that test before, it never got to the screen where we could look at the fuel tank pressure, which is what I'm looking at here, and watch the fuel tank pressure drop. It would fail before we would even get to that screen when we had the purge valve issue. I never got a chance to look at it from my memory. I never got a chance to look at it. It legit failed before it even got there. So we know the purge valve's working as it was not before. And then as far as the leak tests go, I mean, look, we smoke tested this thing how many times, and every single time we smoke tested it, there was no leaks. We closed the vent valve works perfectly. The ball drops all the way down on the smoke machine to 0, so no leaks. And that really left us, you know, we were fighting the whole time, gas cap, purge valve, right? In this case, I believe this time our gas cap was not tightened enough. This is a aftermarket cap. We should have never changed it, and we probably wouldn't have this problem. Just make sure that when she's putting fuel in this, at least 3 to 5 clicks on that cap, okay? And then we should be good. I think we're done, guys. I hope we're done. Of course, if it comes back again, we'll bring you guys back with us. I hope you enjoyed this case study. I know I didn't enjoy it at all. I'm sure the footage of this is gonna be awesome. And I swore the last time that I would never do another Evap leak video again. This is family, so I kind of had, you know, my hands were a little bit tied on that one, but I don't know. I guess it made for a good case study. Guys, thanks for joining us. See you. And we're back.